We're going to be studying now an electrocyclic reaction. This is ring opening. In this reaction, what will happen, the movement of electrons is the following. So you will open this up, and we're going to open that to form a triene structure. So this is now going to have a double bond here. And notice that in the initial structure, I'm not drawing where the metals are on purpose. We're going to figure it out. Here again, you're breaking this bond. This is the bond that I broke. And now we have added a double bond there and double bond here. It had changed. When you do that, the outcome under thermal condition, this should be just a triangle. So under thermal conditions, you have one outcome, and under photochemical conditions, you have a different outcome. You just throw the skeleton in less. Where are the metals now? So the metals here are, say, pointing towards you, right? So they are, or they say up, up, up. What happens under thermal conditions, say that you see my two fingers pointing up, is that, and these are the two metals. What we're doing now, what is observed under thermal conditions is that the ring opening happens in this fashion. So notice this opening like that. What that will do is now this metal here will end up over here. Right, so again, let's do it again. The two fingers represent the metals. So if I do this, this is that metal. And what is found, again, experimentally, is that this one moves over there. So I'm going to draw it opposite side. So this is found experimentally. And now, but if we do now the reaction under other conditions, not thermal, but photochemical, what is found is something else. So now we have the two metals. What is found is that one metal is still, let's say, rotation in one direction, and the other is like that. So how can we explain that? Notice that we have rotated in different ways. If we have the two metals pointing up and we want to get the product again, which is what you isolate experimentally, this needs to move this way. So up, up, this that way, and the other on the other way. In my repeating that here. So they're moving into opposite direction. That movement, moving, say, this like that, and this like that, opposite is called disrotatory. Disrotatory motion. And I'm just gonna erase the arrows here and put it right where the word is. So, okay. So now, what I mean again, they are rotating to different sides. Here's the two metals, and one is rotating to that side, and one is rotating to that side. That is disrotatory. Notice that we can do disrotatory like that, or like that, going outwards or going inwards. Going opposite side is what we call disrotatory, and we did it like this to get from here to here. Now, to get the product that we obtain photochemically, what has happened is that the first metal had rotated like that, but this that was up also rotated that, but now it came inward. Again, those are like that, and they did that. And so what is this rotation? This rotation was the metal up, rotated that way, and they're rotated in the same direction. That is called conrotatory. Okay, so we find experimentally then that when you do an electrocyclic reaction involving 6 electrons, here I'm using 2 electrons, and I'm moving 2 here out of the pi and 2 of the pi. So the movement involves 6 electrons overall. When the system in ring opening or closing involves, say, 6 electrons, so 6 electron, and the condition is thermal. That movement that is observed is disrotatory. And if you have in your system, you're doing 6 electrons again, but you're using photochemical conditions, the movement is conrotatory. So to understand how's that movement, you probably have seen emergency room doors. They open like that as you get into that room. So that movement opening in different directions will be disrotatory, or they can move like that, right? So that is your disrotatory. This movement I call, say, most windshield wipers are like that. So you will be cleaning your windshield like that. There's new cars that have a different, but most of them will have it to the same side. So my conrotatory is my windshield kind of cleaner moving. So in summary, we have that. That's observed. And that conclusion is important. In another video, we're going to see what happens when we have a system doing electrocyclic reaction involving 4 electrons, not 6.